Hi, and welcome to the videos for Chapter 2 for Math 126. This is Section 2.1, and this is the first of two videos for this section. In Chapter 2, we're going to be looking at functions. And any possible function you can imagine, we're going to be seeing it here. So first, for Section 2.1, we want to know what is a function. So, the simple definition, or the simple idea of what is a function, is that one quantity depends on the other. So, for instance, a person's height might depend on their age. Obviously, if you say, whatever, there's a 30-year-old male, you have a rough idea what their height might be, versus a 6-month-old. You know that height. So, one is dependent on the other. Or the one you guys probably know the most about is your paycheck versus how many hours you work. If you're paid $8 an hour and you work 10 hours, you get $80. So one value is dependent upon the other. The formal definition is as follows. A function f and so you notice this is a little f compared to capital. This is our function name. And it can be anything. So you could have the function g, the function h, function whatever. But for our formal definition, we use the small letter f. So the function f is a rule that assigns to each element x in a set A exactly one element called f of x. So this notation here, when we see that, what we say is f of x. So the function of x. So we have this one element in our set A. We take that value x, we apply this function, and this generates a value in set B. So visually, what this looks like. So actually, let me let you get caught up. If you want to pause, catch up with the writing, that's fine. But I have some set A here. Maybe it's the real numbers. Maybe it's integers. Maybe it's the natural numbers. So if we're talking about a paycheck, you wouldn't have -3 hours. You would have what? 1, 2, 3, or I guess you could have half hours, things like that. But we have our set A. We have our set B. So if I have some value, let's call it x1, in our set A, if I apply this function, f of x1, to that value, it generates one and only one value in set B. That's what a function is. It takes one value x and assigns another value in B, a different value. If I have a value x2 and I apply that function onto x2, so f of x2, that generates some other value over here in B. So the point being, it is assigning one value. So if I work, what did I say? So it was $8 an hour. If I work 10 hours, I get $80. It's not like if I work 10 hours, I might get $90 or I might get $70. No, the function is however many hours I work, multiply that by the rate, and that gives me the one value in my set B. So more familiar, what you'll see more often than not is that y can be used in place of f of x. And in this case, x is the independent variable and y is the dependent variable. So, for example, well, actually, let me, before I give you another example, let's say that our function is however many hours we work, multiply that by 8. So x is independent. X can change. I could work 10 hours, I could work 12, I could work 40. Y is dependent. Y doesn't get to vary. Y is only 8 times however many hours we work. So we pick some value for x out of our set A, apply the function, so if it's a paycheck times 8, that gives us our value in B. So what we might see is that f of x, this function, if I am saying again, I'm getting $8 an hour, so that would be what? 8x. If I work 1 hour, I get $8. If I work 3 hours, I get 8 times 3 or 24. So what we're saying here is that we can replace this f of x. The same idea as saying y equals 8 times x. So these guys, you can kind of interchange them. They're meaning the same thing. Y is the same thing as writing f of x. So let's look at an example here. Now, it's kind of the definition and the idea behind what exactly is a function. When we say function, what are we talking about? And it's that we're taking one value, applying it into the equation that we have to generate another. So let's say I have f of x is equal to x squared plus 4. So I want to evaluate 3 different values. The first one I want to know what's f of 3. Well, what this means is, whenever I see this, and I point this out because not just 126, but 127, 181, any future math classes, when you have f of some value inside, a number, a letter, whatever, this just means, because we have what? F of x was this guy. So f of 3 is now replace the x. So what we want to do is replace the x in our formula with whatever value is inside of here. So f of 3 just means take the x, change it to a 3, and then complete everything else the same. So that's what? 3 squared is 9. 9 plus 4 is 13. So if f of x is x squared plus 4, f of 3 is equal to the value 13. I plug it into the equation, that's what it kicks out as my value. What if I have f of negative 2? Same idea. Wherever I have an x in the equation, I just put now a negative 2. So if I plug in negative 2, I have negative 2 squared plus 4, which is what? Negative 2 squared is positive 4. 4 plus 4 is 8. And lastly, what if I have f of a? Like, okay, what happened to the numbers? We went from 3 to negative 2, now we have a letter back in. Well, in these first two, what did I do? All I did was plug in 3 for x and calculate it. Plug in negative 2 for x, calculate it, simplify it. Same idea here, it's just now instead of a number, I'm plugging in a wherever I have an x, so I get a squared plus 4. And that's it. I don't go any further than that. Just plug in that letter, simplify it if I can, and I'm done. Obviously, I can't go any further. I don't have any numbers, so I'm not going to get a number like 13 or 8, but I end up with a new expression. So if f of x is x squared plus 4, f of a is a squared plus 4. And that's it. That's the end of video 1. Sort of a quick introduction into the formal definition, what is a function, and then how can we evaluate a function given values to plug in. So come on back, we'll look at video 2, and that'll wrap up section 1.1. Section 2.1.